Howdy, folks, and welcome to your storm chasing forecast show for Wednesday, July 1st. We are officially into the month of July, and Cameron Nixon, we've got a barn burner for the folks today. A real crazy storm chasing experience for people who are brave enough to dare the Minneapolis, plains.
And the Rochester.
I'm Gabriel Harbor, of course, and I just want to ask you guys something real quick. I wouldn't usually do this at the top of a show, but we've decided that since we had such a great response to these shows throughout the month of June, we'd like to start doing them for lesser storm chasing days because we do have such an awesome core audience that we've built. So if you enjoy these shows and you would like us to do them for not just the big days, but also these smaller days, please subscribe, leave a comment down below, share the episode, all that jazz, because those are all engagement signals that are going to let us get the feedback we need to know if we should continue doing these or not. No more desperate pleas. Cameron, let's tell them about this menace of a setup today across Minneapolis and see if anybody's maybe got something out there they want to go storm chasing with.
Yeah, as you can see, pretty broad enhanced risk area, and we're in the end of June, early July. This is more than likely kind of a derecho ring of fire style pattern here. So just kind of priming you for what we're looking for today. And we have a very broad area of tornado chances throughout this corridor, but also lots of wind chances. If my computer would load, there we go. And very broad region of hatch wind. So definitely a wind-driven risk. Again, things gets you thinking about long-lived damaging windstorms. So let's look at our upper level pattern. And we have broad kind of west-southwesterly flow overspreading much of the area. There's no real kind of large trough or shortwave and 500 millibars. We're just sandwiched here between this massive kind of ridge here in the southeast and then some troughing up in Canada. If you go down a little bit more, similar story, not much in the way of any shortwaves down here. So this might not exactly work in our favor if we're looking for kind of a more organized pattern. You could see a shortwave kind of coming up from the southern high plains, but up here in most of our area, we just have that strong mid-level flow. Our surface pattern is similarly amorphous, if you will. Broad, kind of well-mixed worm sector here, and then just a diffuse stationary boundary, maybe another kind of boundary out here. If you look at dew points, not a whole lot in terms of sharp gradients pretty much anywhere across the risk area, with the exception of maybe central South Dakota into southern Nebraska. So diffuse is definitely the word today, and it's going to be tricky to predict where exactly storms are going to want to fire.
Excellent word to end on, because you mentioned ring of fire earlier, and
Yes.
I think a lot of people might be interested in learning exactly what that means and how it relates to severe weather setups this time of year.
I was hoping you were going to say people are interested in hearing me sing Ring of Fire. But yeah, so what often happens with this setup is you just get a very strong high pressure center. Oftentimes when you're dealing with kind of your classic Corn Belt and Midwest derechos, this high is positioned more towards the central plains. It's folks like me and Norman who are just absolutely baking in the heat and the sun. But this looks a little bit different than that. Our high is scooted east over the eastern US. And what you get are these, we call them ridge riders, that ride this ridge here. It's an active storm track that you get any little shortwave or impulse here along this southwesterly flow, and you get these MCSs that kind of ride along the axis of the ridge. So it would not surprise me in this kind of setup to potentially see severe from Minnesota, Wisconsin, Michigan, even into the Northeast. And if you look at kind of SPC's risk area, I swear I didn't actually look at this, but we do actually have a slight all the way up into the New York and Vermont, New Hampshire. So this is a classic Ridge Rider setup.
I appreciate you sharing with us what the Ring of Fire means. That's such a cool way to visualize it right there, just with the SPC outlook. You literally see the Ring of Fire rotating around the high pressure area. And the Chaser Academy is the best deal in storm chasing, and it costs less than a combo meal at McDonald's. Unlock instant access to exclusive storm chasing presentations, participate in live group coaching sessions, and get answers to all of your questions in the unlimited Q&A chat. Whether you're a beginner, a a veteran, or somewhere in between. Our expert coaches will help you take your storm chasing experience to the next level. Click the join button below this video or on our profile page and enroll in the Chaser Academy right now. If you could actually, down at the bottom, what is with the little area of marginal risk on the south side of that high pressure system? How does that work as well?
Wow. Yeah, good question. Sometimes you actually get, I'm predicting again, this easterly 500 millibar flow. And if you look at, yep, there it is. You get this kind of extension of that ridge. And oh my God, let me pluck some soundings just to show you how absurd this probably is. We're finding way more to talk about today than there actually is to talk about. But look at that. Look at that. So you have easterly 500 millibar flow. I guess this would be a left mover favored hodograph because you have some anticyclonic curvature. And then you have this monstrosity of a skew T. If you're chasing in central Alabama, you might have some fun.
Is it ever possible to get a tornado with easterly deep layer shear?
I'm sure there's some. So Arizona, actually, I almost called it Australia. I need sleep. Arizona in their monsoon season actually deals with this easterly mid-level flow a lot. These storms kind of emanate off the higher terrain in southeast Arizona and kind of move westward. And so I think it's possible that you can get tornadoes with that, but it's just what kind of area deals with this most frequently.
I knew I could get you into Professor Nixon mode if there wasn't a whole lot to talk about with the actual forecast. So I'll let you get back. I'll let you get back to it and take us back up north and share with us what you're seeing up there.
Yeah, let's do this a little bit more justice. I don't think it's going to be a total snooze of a day. We got enhanced risk. I think just the issue is going to be where storms going to initiate and what's the environment going to be like. And so, as you see, we're looking at 4 p.m. Our surface pattern is very diffuse. You do have, though, that kind of stationary front here, southern Minnesota into Iowa, South Dakota, and Nebraska. And then you maybe have a kind of well-mixed air mass out here that could also initiate a couple storms. And you also potentially have the remnant outflow boundary from this morning's MCS cruising across southern Minnesota. So lots of potential triggers. And I'm guessing here that the remnant MCS outflow boundary will help trigger this kind of stationary boundary when maybe it might not trigger by itself. So that's why we're honed in on southern Minnesota, northern Iowa, because this is where this morning's MCS is likely to end up, the boundary from that. So if we let's just look at Cape, and let's actually look at her Cape, just because this setup is so kind of diffuse. The her might show us a little bit better where some of these features are. And as we see, we can recover from this morning's MCS likely pretty quickly. And generally, soundings look pretty good for supercells, some nice mid-level shear, and potentially convection initiation in this area. Some other soundings I've seen were very moist and with perhaps a little bit lower of LCLs, but these seem pretty good for CI and even relatively decently photogenic supercells for a minute there before they grow upscale. Farther down into maybe Nebraska along the stationary boundary, it's probably going to be a little bit more dry, especially aloft, and it looks like that is the case. And shear is going to be a little bit weaker outside, again, that kind of active MCS storm track. And if you go up into South Dakota, let's see how dry we get up here. Quite dry, but still some relatively good low-level buoyancy and strong deep layer shear. So would not be surprised to see, this would be my hipster play up in South Dakota, a nicely structured photogenic supercell or two up in South Dakota if that were to actually form. I think the issue is the later convective evolution. Once you have this morning garbage stroll out and maybe even becomes a fairly strong damaging wind producing event, what is it going to look like here once the powder keg is kind of loaded in the early evening? And I think this is where moisture really starts returning. You get those 70 dew points, really big Cape, and even some low-level flow and SRH here. Some soundings I've noticed, though, or some evolutions are a little bit different. maybe the NAM might have this kind of a solution where any storms that do form later on in the evening might actually be elevated. And let's see if, yeah, this actually shows a little bit of this, where you have a lot of remnant moisture just off the deck from these MCSs, and this moisture could actually be triggering elevated storms later on in the evening. So it's really, I hope you can hear the uncertainty that there's just so many different potential ways convection can initiate, and it's not exactly certain what we're going to get later.
Time for everyone's favorite part of the show, Cam versus Cam. What are we looking at?
Cams with Cam. Let's go. So let's see if the HRRR generally has what we've been thinking. Moist and unstable air mass during the day, not exactly surprising that you'd see some sort of early development. Again, turning into kind of a damaging wind swath. Might be a couple of these today. And then behind this recovering air mass, you do get some storms in Iowa and Minnesota. But as I was clicking around, some of these soundings do show that mid-level moisture here, and these could potentially be elevated storms rooted above the boundary layer. So again, not too sure if these will be worthy storms to chase or even have a tornado potential, but they are definitely probably the most obvious option. Maybe looking into South Dakota, the HRRR usually runs pretty dry, so you really don't see that much stuff there. Maybe if we look at the Rufus, we get a little bit of a different story. Looks like the midday stays a little bit drier, and then more storms pop at prime time. You can see this smattering, right? This unorganized complex of storms just because of how diffuse our surface pattern is. And then maybe you get some excuse of a supercell or two in South Dakota, which again would be pretty photogenic. And then NAM, just got to cover all of our bases. See that keeps the remainder of today pretty dry, and then again waits to pop till kind of prime time evening hours. Maybe get a supercell here, looks fairly messy and quick to grow upscale here, and then maybe some more convection that really struggles to become supercellular in South Dakota.
Now, for our chasers who are out there today and are wondering whether or not some of these storms are elevated, like you've suggested they might be, what are some visual indicators that will help them recognize that and maybe move on to a storm in a better part of the environment?
That is a really good question. And let's see if I could pluck a NAM sounding in front of this to maybe. Interesting. Yeah. So this actually does teach a fairly good lesson, and that's that convection can really happen in just about any layer. We can get it from the surface. We can get it from this moist layer here at 850. We even get it from 700 in the sounding if you're moist enough. And so what you're going to notice when you're looking at storms is that if these storms are truly surface-based, they're going to be emanating from a low-level turbulent cumulus field. Just your classic poofy clouds kind of sky, where you have kind of this unstable mixed layer or this unstable air mass. If your storms are elevated, you're likely going to see more of a stratus sheet. So maybe in this sounding, we actually have a stratus layer at around 800, and then you don't see these cumulus near the ground. So definitely when you look for elevated storms, look for kind of this dense stratus and or things like altocumulus castellanus or altocumulus undulatus. All of these are signifying that there's another moist layer somewhere above that could be triggering convection.
You really worked hard on your Latin, I can tell.
Thank you.
Remember to check out those links in the description below, and then watch another video.